Hello. Today we're going to be looking at how to factor a polynomial with a factor that's already given and it has real and imaginary part. I'm really going to expand upon a video that's already there, but it leaves out a few details, I think. We're given this polynomial here, and we know that x equals 5 minus 4i is one of the zeros of the polynomial. First, by the fundamental theorem of algebra, we know that since the degree of the polynomial is 4, we're going to be expecting 4 zeros total for this polynomial. They could be imaginary. In fact, we do have one imaginary. They could be real or they could be repeated. One other theorem we can use is when we have a zero with imaginary part, thinking about the quadratic formula, if we have 1 0, well, we would need plus or minus the square root, so we would also have its conjugate 0. If we ever have a 0 with an imaginary part, we also have a conjugate 0 coming along too. So in this case, if 5 minus 4i is one of the zeros, then by the conjugate 0 theorem, 5 plus 4i, the conjugate where we change that sign in front of the imaginary part, is also a 0. We're going to need to bust this polynomial down into a second degree so we can use the quadratic formula. We have 2 linear factors here, so if we can create the linear factors and multiply them together, we can divide to get that other polynomial, that quadratic, to help us factor and solve this polynomial. So what we do next is we create factors out of these zeros. If 5 minus 4i is a 0, then x minus 5 minus 4i is a factor. If 5 plus 4i is a 0, then x minus the quantity 5 plus 4i is a 0. I can multiply these two out to get a quadratic factor, and I'll distribute an x times an x. That will give me my x squared. The outer terms, I have a negative 5 minus 4i times x, and I have a negative 5 plus 4i x. So the 4i cancel, and I have negative 5, which would be a negative 10x. And then I can actually distribute the last parts here. So when I distribute the 5 minus 4i and 5 plus 4i, I'll get 5 times 5, which is 25. Middle terms would give me minus 20i plus 20i, so those subtract out. And then I'll have a minus 16i squared, which is going to be a plus 16, because I squared is negative 1. That will give me the 41, which you see right here. This polynomial here will be a factor of the original one because it takes into account these 2 imaginary zeros. Now to find the other 2 zeros, I'm going to divide this polynomial into the original one. And I'm going to have to use long division to do that because it's not a linear factor. So I take this polynomial here and divide it into my original. So I just do this term by term. What times x squared would give me x to the 4th? Well, that's x squared. If I multiply x squared times each of these factors, I get this polynomial here. Subtracting, I always like to change the signs on these so I know what I'm doing. Negative 2 plus 10 is 8. Negative 32 minus 41 is negative 73. And I bring down my next term. I ask myself, what times the x squared would give me 8? X cubed. Well, that's 8x. Multiplying 8x into all these, I get 8x cubed, negative 80x squared. And 41 times 8 is 328. So again, I changed the sign on these. And this one should have been a plus. And when I subtract these down, I get negative 73 plus 80, that's 7. 258 minus 328 is negative 70. And I'll bring my last factor down here, my last term. What times x squared would give me the 7x squared? That's going to be the 7. Multiply through by 7, 7x squared minus 70x plus 278. So changing the signs, I get a remainder of 0, which should happen. So this is my other factor of the original polynomial here. So now I know this polynomial factors into this one from the imaginary zeros that were given, and this one I got from long division. The last thing I need to do is factor out this polynomial. So my x squared plus 8x plus 7 factors into x plus 7 and x plus 1. And I will have my polynomial factoring down into my x squared minus 10x plus 41. But these were the two real and complex zeros I had multiplied together. So those are the factors that gave me those two. And then it's times this polynomial here, but that gave me x plus 7 and x plus 1. So the entire polynomial will factor into these four factors, which would give me the four zeros of 5 minus 4i, 5 plus 4i, negative 7, and negative 1. I hope this helps you out with a problem like this. I know it's difficult to multiply those together, but hopefully this example will help you wrap your mind around this a little bit better. Thank you.